In the last lesson, we learned that the main 3GPP protocol versions relevant to 5G are Release 15 and Release 16. In Release 15, two phases of 5G development were described. First, a network with non-standalone architecture was defined, and then later, one network with standalone architecture. So, what do we mean by non-standalone network, and what do we mean by standalone network? In a literal sense, non-standalone architecture means that the 5G network cannot be deployed without a 4G network also being deployed. The 5G network cannot stand alone. With a standalone architecture, the 5G network does not require a 4G network to function. The 5G network can stand alone. The networking types supported by the current protocol are shown here. In a standalone 5G network, the following conditions must be met. 1. A next-generation core network, a NGC, must be deployed. 2. The NGC must send NR control plane signaling directly to the 5G base stations. If these conditions are not met, it can't be called standalone networking. It's non-standalone. Typical NSA networking. First, let's look at the most typical NSA networking scenario, the Option 3 series. The series includes three networking modes, Option 3, Option 3A, and Option 3X. As you can see, these three options are almost the same. In each of one, the core network is an EPC. The wireless network is LTE and NR, and the signaling plane is anchored on the LTE side. However, there are differences. In each option, the service data on the user plane is handled differently. In Option 3, the user plane traffic distribution is handheld on the LTE base station side. The distribution is dynamic. Traffic is dynamically allocated to LTE or NR base stations based on signal quality. However, this type of dynamic resource allocation puts a lot of transport pressure on the existing LTE sites on the live network. Large-scale upgrades and reconstruction of existing LTE sites are required. In Option 3A, the user plane traffic distribution is handled statically on the EPC side. The traffic is distributed between the LTE and the NR sides in a fixed proportion, regardless of signal quality. This ultimately results in a user experience that is not as good. In Option 3X, the user plane traffic is distributed by the NR base stations. This option is dynamic, like Option 3, but this option does not put the same transport pressure on the existing LTE sites. With Option 3X, you do not need to perform large-scale upgrades and reconstruction of existing sites. As such, this is the first choice for 5G pilot networks. So that's the Option 3 series. Now, let's take a look at the Option 7 series. Do you see how the Option 7 series is different from Option 3? It's the core network. Other than the fact that the core network has been replaced by an NGC, the Option 7 series is the same as the Option 3 series. As the control plane signaling is anchored on the LTE side, the Option 7 series options are all types of NSA networking. We can think of the Option 7 series options as transitional schemes that can be used for evolution from the Option 3 to an SA networking. Let's take a look at a typical SA network. SA networking includes the Option 4 and Option 2 series. The Option 4 series includes Option 4 and Option 4A. Once again, these three options are almost the same. This time, in each of one, the core network is a NGC, the wireless network is NR, and the signaling plane is anchored on the NR side. Also, once again, there are small differences between the options, mainly in how the user plane data is distributed. In Option 4, the user plane traffic is distributed on the NR base station side. The traffic is distributed dynamically, but it does not place significant pressure on existing LTE sites. You do not need to perform large-scale upgrades and reconstruction of existing sites. In Option 4A, the user plane traffic is distributed on the NGC side, but the distribution ratio is static. The traffic is distributed between the LTE and the NR sides in a fixed ratio, regardless of signal quality. This ultimately results in a user experience that is not as good. Option 2 mode is extremely simple. The core network is ANGC and only NR is available on the wireless side. This is the ultimate goal for the 5G networks of the future. In all three of these SA networking schemes, the signaling plane is anchored on the NR side. So, if we want to rely on SA networking, we need better NR coverage. With so many networking solutions to choose from, how does a network operator choose which one to use, or which one to deploy first, and which one to deploy later? Well, that's why we have an evolution roadmap. The figure shows two different routes. They both start with an LTE network architecture and end with the option 2 architecture. However, there are many differences between the two routes during the evolution. In route 1, on the top, we start with the LTE architecture, and then move on to option 3X. From option 3X, we can jump directly to option 4, and then finally to option 2. This pathway bypasses the option 7X solution. This pathway to option 2 is for operators with good NR coverage. In route 2, on the bottom line, we still start with an LTE architecture and then move on to option 3X. But then we move on to the transitional networking option, option 7X. Option 7X networks can then be evolved to option 4 or option 2. The entire route includes two NSA scenarios. This pathway is better for operators with poor NR coverage. This lesson has gone over the 5G networking solution, including both the non-standalone and standalone networking. Typical NSA networks include option 3 series and option 7 series configurations. Typical SA networks, in contrast, include option 4 series and option 2 series configurations. And when evolving networks towards the target 5G network configuration, option 2, there are different routes that can be taken, as needed, depending on the NR coverage available. In the next lesson, we will discuss some 5G key technologies.